New technology, but it requires that I use this guy. Not my favorite thing in the world to use the microphone, and we probably better shut the door. Otherwise, the whole world is going to hear me. They already do, kind of, but when I have a microphone on, sometimes I forget I don't have to talk loud. Like, I could literally whisper right now, and you could hear me just fine. But I get really excited when I'm teaching you about math. So, anyway, so just so you guys are aware, if you didn't get my announcement on Canvas, because of the new technology, like the creepy camera that can watch us at all times in the back. Yeah, you're welcome. So don't commit crimes in here. Anyway, because that is there from now on, if you get quarantined or if you're just sick or your car broke down and you stayed home, I don't know, whatever. For whatever reason, if you are not here, I think I will probably just plan on live streaming this class, just because this is the one I teach first, my A2 class. And then I can just post the recording so that anybody that misses A4 or V3 could just go back and watch this class. I don't know. We'll see how it works. But for right now, just so you know, that is an option to just hop in my Zoom room. And the link will never change. Like, I don't need to send out a link every day. Just go back to that announcement that says Zoom class, and there's a link in there, and it will work every single time. So anytime you want to hop on and see what's happening in math. I will also post the recordings so that, like you guys that are in here today, you're going along in class and you're like, yeah, I've got this. This is so easy. And then you go to do your assignment and you're like, holy crap, I can't remember anything she said. So then you could go back to the video if you needed to, whether it's to jot down a few notes or just remember what I said. I know she said something about this, but I didn't write it down. Go find it in the video. It's there. Okay? If I was cool like Mr. Meyer, I would like timestamp my videos to like say where things are in the video. But I don't know how to do that, and I'm not planning on working that hard on it. So sorry. You'll just have to scroll like a commoner. Okay. All right. The first thing I want to do, like I said, is to go over any questions that you have from those previous assignments. So anything we did last week or even the week before, questions from the pink or the gold specifically, really. Just refresh everything. I will, but if there are specific questions on pink or gold that you were that you tried but you were unable to do, yes. Yep. Yep. Yeah, I've been there the whole time. Thanks for using that, you know, making all of my efforts worthwhile. It's fine. Whatever. Any questions on the gold or the pink? There have got to be questions. There's no way that you are my first class that doesn't have questions. Are your gold packets all blank? Is that why you have no questions? Because you haven't looked at them yet? You guys suck. Yes. Why? Well, shoot. Okay. That's actually a really good one for us to start with. I will give you warning, though. This is now my 4th time that I have taught this lesson. This whole split schedule, at first I was like, that's great. I only have to plan one lesson for each class every week. Oh, wait. That means I have to teach the same lesson 6 times every week. And it makes me want to cry a little bit. So, I already knew before I asked that you would have a question on number 4 on the gold packet, because everybody had a question on number 4 on the gold packet. But I am going to give you a heads up that this question, if I just show you how to just do this question, it's only going to take maybe 3, 4, tops 5 minutes, okay? But I'm not going to do that. I'm going to use this question as a review to kind of go through some of the vocabulary, some of the stuff we talked about before, kind of start connecting the pieces, okay? So please don't start a timer right now, and when I'm done, say, Mrs. McBurney, it took you 35 minutes to do one question. How are we ever going to get our assignments done? It didn't take me 35 minutes to do one question. It took me 35 minutes to give you a review lesson using this particular example as our guide. Good? Here we go. Okay. All right, so this particular data set, kind of an interesting data set that brings up some quality conversation. This data set is regarding how many years you go to school and how much money you're going to make in your career. Okay? Do you guys think, just throwing that out there, do you think that the amount of money that you make, your salary as an adult, depends on how much education you have? Yes or no? Yeah, probably. Can you tell me, those of you that are like, no, not at all. Can you tell me those big exceptions that you're already thinking of? So he makes a decent living, probably the same living as someone that has like at least a bachelor's degree and he didn't even graduate high school. Great. What else? Start your own business. Connections. Can you play sports? Like professional sports? Do you have to have a degree to play professional sports? No. Do you make a little bit more money than I do? Maybe. Just so. Let's talk about the people that make less money than me. Stay-at-home moms. Yeah, good job. Great. Good talk. Okay. Fine. I can handle it. Okay. Okay, what does that say? What does an average education of 14 years mean? Good. Yeah? You guys, I don't remember who it was, or I would totally say their name and make fun of them right now. Who was it? Somebody on Monday. So somebody in my B3 class. Was it? I don't think it was them. Who was it? Oh my gosh, it was so funny though. Anyway, I kept saying I have 16 years of education. And I was like, oh, maybe 17 or 18 if you count any of my master's classes that didn't ever create a degree for me, but it's fine. So I kept talking about like 16 to 18 years of education. And finally, he's like, stop. You went to college for 16 years to become a teacher? Like, yeah, obviously. It was like the whole class was just like, fine. It was pretty great. Okay. And income. So how much of education do you guys have? So the way that this data is collected, you guys are at almost 11 and a half. We don't count kindergarten and preschool and all that gibberish. Okay. They count the end of first year, they say you have 1 year of education. Second, third, fourth. Yeah? So when you graduate high school, you'll have 12. Okay. And then the SD, 26,000. Okay, talk to me about average income. Average income for this particular data set. So this is women between 25 and 34 years old. Okay, do you know any women that are that age? I wish. Oh, okay. 29 forever. Okay. Fine that I have a 16, almost 17-year-old. It's fine. Don't worry about it. Okay. So average income, $32,000. So 25 to 34-year-olds are generally speaking people that have already graduated college if that is their plan. Yeah, kind of depending on where they're going. I mean, med school might cause slight disruptions there. But anyway, so these women have an average income of $32,000. Read the rest of that line for me. Standard deviation of, say that number? top line says this data set, the average person has about 14 years of education, give or take 2.4 years. So that's about how far off I expect to be. Yeah? Or we could say the majority of the data set is somewhere between 14 minus 2.4 and 14 plus 2.4, right? That's what our SD is. It's a measurement of how far off of average most of our data is. So read that second line again with that context in your head and tell me what you're thinking. About a little bit of a large SD. Imagine, like, just to make, you know, okay. Well, I walked up to Peyton, and I said, Peyton, how much money do you think I make? If Peyton said, and I quote, probably like $32,000, give or take $26,000. So Peyton is saying that I make somewhere between $6,000 and $58,000. Way to venture out there and really be bold and brave and make a guess. I mean, seriously. Yeah, hopefully. He sees how much I work and how many tiers. $6,000? Are you serious right now? Like, come on. Okay, but that is like, that SD, that's quite the cushion, I guess. Yeah? That's like walking up to a middle-aged woman and she's, how old do you think I am? 20, give or take 20 years or so. You just sound like an idiot. Yeah, you are clearly somewhere between 0 and 40. Good job. Yeah, like it just sounds stupid, okay? But that's what an SD is. In this case, the reason the SD is so freaking large is because there's so much variability. Why with women in that particular age group is there so much variability in their incomes? Feeding your fat face. Yes, that is what they waste their money on. Oh, I just want to punch him in the face sometimes. Fine.
We can't do it now.
I also have to watch my mouth. I told them when they installed it, I'm like, I'm not supposed to swear now, right? He's like, what? I'm like, never mind. Carry on. Carry on. It's fine. Just not during the classes that are live streaming. So maybe you want to pick another class period. Okay. Sorry. Anyway, I missed you guys, obviously. I don't get to laugh like this in my other classes. Okay. So I was saying something of importance. Oh, variability. Yeah. So maybe there's some really amazing stay-at-home moms who are sacrificing their career to hold their home together to make sure that their children feel loved. Yeah. Their income would be a zero. Whether they have a bachelor's degree, a master's degree, an associate's degree, they barely squeaked by high school, it doesn't matter. Their income is, in this data set, is counting as a zero because it's personal income. It doesn't count their spouse, okay? All the way up to what? What's on the high end of that? 25 to 34-year-old women who makes a lot of money. They could be a CEO. They could be someone that went to medical school. They could be a surgeon by then, right? They could be making an amazing amount of money. Yeah? Managing some sort of store or business or something. They could be making tons of money. Or they could just be middle of the road, like me. Okay? Just plugging along, teaching ungrateful little humans, fat faces. Okay. All right, anyway, so huge amounts of variability. What else? Now that I say that, I'm going to write it on the board. What else is there about this information that tells you there is a huge amount of variability? Yeah, what is R? What is it telling us? It's how tight that data is. It's how closely correlated how much education you have is with your income. Is 0.34 a high number? No, like that's pretty crappy. Might as well be zero, if we're being honest. Yeah, 0.34, you can barely even tell that the data is sloping upward. because it has so much variability. It's just this huge blob of dots that are barely moving in an upward direction. Yeah, you don't see that tight cluster. It doesn't look like a tight line. Okay, all of that. So a combination of this and this tells us that we're going to go to a lot of work right now to figure out how to make predictions using this data, and our predictions are going to suck. Pull out a calculator really quick. Type in 0.34 times 0.34, or just 0.34 squared. What do you get? 0.1156. Turn that into a percentage. 11%. So when we go to the effort to find the regression equation for this data set, so that we can use it to make predictions, so that when someone walks up to you and says, so, I have 18 years of education, how much money do you think I make? Okay, we're going to use the regression equation to make that prediction, but guess what? We're going to be right 11% of the time. Based on this R value, our predictions are expected to be accurate 11% of the time. Yeah? If I offered a class at Payson High School and said, by the way, only 11% of students pass this class, would you sign up? No. Challenge accepted. Yeah, that sucks, right? 11% of the time, I'll send you your paycheck. Really? 11% of the time, I'll mark you here when you're actually here. 11% of the time, your car will start when you need to go somewhere. How accurate. This feels relatable. Okay. All right. So we know we're not going to get a whole lot of accuracy. We're going to use this question anyway because it's kind of a fun, interesting data set. But then we'll do something with a little more accuracy in a minute. So on your blue cardstock, this is called your formulas page. And I gave it to you and then we didn't really use it. So we have already passed all the information that you will use when you take test number 1 for UVU, which doesn't happen until January, okay? But on test number 1 from UVU, you might need to know Z, you might need to know what an outlier is, and you might need to know what an IQR or an interquartile range is. Hopefully those things look relatively familiar. Everything we've done in the past couple of weeks and everything we will do the week after Thanksgiving comes from test number 2 from UVU, and that is all located right there. Okay? Now, I know you're probably looking at test number 3 and test number 4 and thinking, holy crap. It's not that there's really more math to do, there's just more fancy little formulas and more scenarios, so we just put them all on there for you. Yes. Okay? You're not supposed to write on them, no. Okay? If UVU ever shows up to proctor a test, then you would have to show that if you wanted to use this, you would have to show them that it's just the original formulas page. It doesn't have any more writing on it. But you can use, if there is ever anything that I tell you to add to this, then we can just pull out some sticky notes and you can add it with a sticky note. And then you would just have to pull that sticky note off for test day is all. No big deal. Okay? So when I made this, basically UVU sent me, I wish I had it still. I probably have it somewhere. Someday I'll have to show you guys. They sent me this chicken scratch page of all the formulas that you would be allowed to use. I mean, like appalling handwriting. Formulas just like all over this page. And they're like, here, this is what they can use. I'm like, you want me to give that to my students? Yeah. No, I won't. Thank you, though. Anyway, so I typed it up. And this is not the order in which UVU gave me the formulas. But in my mind, I'm thinking, gosh, if I wanted to help my students, how could I help them? Well, I would love it if on their formulas page, I could just say, step 1, do this. Step 2, do this. Step 3, do this. And I didn't feel like UVU would be okay with me adding that in. So instead, I just put the formulas in the order that you actually need to use them. Step 1, find the slope. Step 2, Write the equation of the line using either of those options. Do you see them? Y equals mx plus b, or y minus y equals m minus times x minus x, yeah? So that's step 2. Step 3, you'll calculate the RMS error, which we will talk about today. That should not look familiar to you yet. We haven't talked about that. Okay? So let's do question number 4, now that we've talked about it for a while. Question number 4 says that we are supposed to estimate the average income for women who have finished high school but have not gone on to college. According to your formulas page, what is step number 1 here? Find the slope. Okay. A while ago, we talked about the SD line. SD line had that slope, SDY over SDX. Then while Karanda was here, you were introduced to the regression line, which has that slope. Okay? So if you've got to go back and do some old assignments and you're supposed to be doing something with the SD line, just remember the only difference between the regression line and the SD line is that little R right there. So if we just get rid of it, that's the SD line. If we leave it there, there's our regression equation. Okay? All right, so we need to just plug numbers in. I know what R is. It's right here. But I have a question. How do you know? Because this says SDY. I have 2 SDs, and they aren't labeled as Y and X. How do I know? Why? Why does it make more sense? Okay. Yes. So lots of ways you could look at it. First of all, Y is the one that you're trying to find, right? Even back in algebra, I give you X, you find. I give you X, you find. We do this all the time, right? So they're giving you 12, yeah? So that's probably X, okay? Also, in statistics, the X variable is called the explanatory variable, right? Explanatory, that kind of works well together. It just means that that variable is explaining the other variable. Does it make sense to you that how much education you have explains your current salary, as opposed to your current salary explains how much education you have? Right? That's a little weird. Yes, they're correlated, so you should be able to go back and forth between them, but it makes more sense that how much education you've got is now explaining your income as an adult, because education came before your job, right? Okay? A lot of times it's thinking chronologically, which came first. Most of the time when we have a data set like the father's height and the son's height, which came first? The father's height. So we use that as the explanatory variable to explain the height of the son. But couldn't you also look at a son, look at a boy, and make a prediction about how tall his dad is? Just as easily as you look at the dad and make a prediction about the height of his son. It works both ways, but we just decide in general that whichever one would be the explanatory, whichever one does a better job of explaining, that would be the X variable on the horizontal axis, okay? Also, pro tip, I have yet to see a problem like this in your textbook or from UVU where it wasn't X on top, Y on bottom. Just throwing that out there. Okay, I don't know why they don't mix it up if they really think it's something you should know. They're basically just handing it to you every time, but it's fine. We'll go with it. Okay, so all that to say, what the heck is the SD of Y? And what is the SD of X? Okay, throw that in a calculator for me. And I think this has to do with money, so I'm just going to go 2 decimals. How sure am I? Let's talk about units for a second. An R value, this 0.34, doesn't have units on it. Okay? But what is $26,000? And what is 2.4? Years. So this number that you just came up with is $3,600 per year. Okay. Told you we were going to go slow. We're still going slow. So we just found slope. That's step 1. Before we move on to step 2, I want you to do a little thing called interpret the slope. I ask you to do it on your yellow and green packet that you're going to work on later. So what does it mean when I say interpret the slope? It means tell me what the heck that number is. And use words like education and income to tell me what that number means. Did you hear that? Okay, does that seem logical to you? Think about it in terms of college. Another year of college, an extra $3,600 on your income. Another year of college? Yeah, you see it? Okay, in general, right? Again, we've got a really low R value, but in general, that's what this number is saying. For every additional year of education a person has, we expect that they would make an additional $3,600. Good. 40 years of college? You go for it. Come back and let me know how that worked out for you. Okay. All right. What is step 2? What is step 2? Yeah, we're going to find the equation of the line. Notice step 2 comes with 2 options. You can use y equals mx plus b if you want. Or, what's your other option? Y minus y equals m plus x. Yeah, apparently that's not your favorite. I take it. Okay, great. That's fine. Step 2, either way, is find the equation of the line. Doesn't matter to me. Okay, so we want mx plus b. Is that the general consensus of the room? Okay. I need to write the equation of the line in slope-intercept form, which means I need a slope and I need an intercept. Do I have either of those? I've got a slope. So I'm going to put slope where? Where is slope? M. So in place of M, $3,683.33. And then can I put anything in place of B? No. Somewhere up here, does it say the y-intercept of this data is? No, it never does. Okay? No, hold on. Not yet. What can I use, though? If I can't put B in, can I put y and x in? These are connected, right? These numbers go together. This is the average education paired with the average income. So x average and y average, those are going to go in here for x and y. So x average is what? 14. Y average is 32,000. And I don't know B. But we can figure out B, right? It's the only variable in that simple equation. So figure it out. And I'll watch your faces to see if you got the answer right. There's a certain look that you make when you think your answer is wrong. What? Or negative 19,000 or so. I can't remember what it is. Did you get a negative? Oh no. Do we not know how to do the math? Okay, look. Multiply those, right? And then do what? Yeah, it's adding B. How do you get rid of it? Subtract it. Okay? So subtract it from both sides, and B turns out to be what number? And how many pennies? Negative $19,566.62. I'm assuming this is talking about money, not years of education. Okay, this is my y-intercept. The other thing I'm going to annoyingly make you do on your next assignment is interpret the y-intercept. Interpret negative $19,566.62 for me. Go. How many years of education do you have if you went through high school? Where does the y-intercept land? Is it possible to go through high school and still make negative $19,000 a year? Definitely. You are a mooch. That is the definition of a mooch. You owe your parents $19,000 a year. Good job. Proud of you. Probably not. Please don't come back and visit me if that's you. I love you, but I want you to come back when you have just $19,000 to say, Merry Christmas. You know what? You made me smile every other day, and I appreciate it. Yeah? Please? Okay. Thanks. Anyway, okay, so Cooper was right in the fact that we're talking about people that don't make any money, and they're kind of just, you know. But this is not after high school. Who is this? This is the people that didn't make it quite through first grade. You made it to adulthood. You are somewhere between 25 and 34 years old, but you never even went to first grade. Do you think that's possible? Does it? I mean, here's the tricky thing about data, is that over there at the y-intercept, it actually doesn't have to make sense. It's okay if it doesn't make sense. Sometimes it will. Sometimes it definitely won't. Okay? Now, step outside of the United States for just a second. Is it possible to have a person, a woman, between 25 and 34 years old that never even went to first grade? Yes. We can't relate because you are born, and then you learn to walk, and then mom puts you in preschool, and then you go to kindergarten, and then you just keep going. You don't wake up one day and you're like, not feeling it. No more elementary school for me, thanks. I'm out. I got lots to do here at home. I'm good. Here in the U.S., that is just not a thing that we're okay with. But are there other countries and other parts of the world where you don't even have the opportunity to go to first grade? Yeah. Okay. Now, I'm not saying that that is the situation in this data set, because I am pretty darn sure that the people living in third world countries were not a part of this data set. Yeah. So this particular y-intercept here, it just doesn't make sense, and that's okay. Okay. But let me show you how it happens. So we have your years of education and your salary, and we have all this data all spread out and crazy. Okay? So you're saying I would have better luck at Pictionary if I just did that than actually tried. Do you want to see a dog? Dog, pig, horse, elephant. Nope, I got you. Elephant. That's my house. Yeah.
This is McMurdy. Can you send Kason Simpson to the office?
Yeah.
Thank you.
I'll also send Caden, because Caden needs to check out as well. Okay, bye. Have fun. Not fun. That's not going to be fun. Yeah. Yeah, for sure. Okay, here's my beautiful picture. here's my point of averages. And then my regression line probably goes through like that, kind of, maybe. I don't know. Not cute, but we'll pretend. The point of averages is 14 years of education paired with $32,000. Yeah? With a slope of what? Slope of? So that means for every additional year of education, I go up $3,683. Yeah? And if I keep doing that, I end up landing here at where? Negative $19,566. Okay? At some point, it just stops to make sense, right? I mean, really, for us in the U.S., how often do we have someone not make it past 8th grade now, in this day and age? Hardly ever, right? It is a very, very special circumstance that someone quit school in 8th grade. But like my grandparents, that was like kind of okay. It was perfectly social, especially, no offense, but especially for girls. Oh, you can just stay home and take care of the house. Yeah, like my husband's grandma quit school in 8th grade because her mom died. And she was the oldest girl, so she stayed home and she made bread and sewed underwear and did laundry and literally made their underwear, guys. Like, you didn't just go to the store and buy it, I guess. Weird. Anyway. So like that she has an 8th grade education, and that's why. Because back then it was different. But in 2005, how many people are there, out and about in society that quit school at 8th, even 9th, 10th? There might be a few in the data set that didn't quite graduate high school. There might be a couple that 10th, 11th grade, somewhere in there, they might have said, okay, that's about enough of that. Yeah, but that's probably about the earliest we would see in this data set. So even points over here probably don't even exist, right? There's probably not a whole lot happening here, and probably not a whole lot of this even makes sense, especially not that y-intercept where someone is making negative $19,000 a year. Yeah? Okay, anyway, we proceed. So we interpreted, oh, go ahead. Well, if it asks you to interpret it, you would say, this says that a person with 0 education makes negative $19,000 a year, which doesn't really make sense. That's your interpretation. Yeah? Sometimes it does make sense. Sometimes it just doesn't. We have a data set that, depending on which data set you collect or which data you keep, there's a data set that relates how long you date to how long you stay married. Interesting data set, okay? So the y-intercept in that data set would be referring to the couples that never dated at all. They got married when they met. Do people do that? How? How does that work? Hey, they got drunk in Vegas and just grabbed the first girl they could see, and yep, there it is. Elvis Chapel, here we come. Okay, what else? Arranged marriages. Not a ton in the U.S., I would say, but there it is. And mail order bride. My half brother-in-law's dad. Yep. I was like, how do I even explain? I don't want you to think he's related to me because he's not. He definitely has one of those mail order brides. He flew her over from the Philippines and they got married the day that she arrived. They had never met. Yeah. So the question then, no. Oh no, can of worms open. Okay. Yeah. They don't live in the same house, but they're still married. And they have a son who is older. No, wait, let me, yeah. They have a son who is younger than their grandson. So my half-brother had a little boy, Like he got married, had a little boy, and then like a year later, he got a little brother from his dad and his bride. Well, when they got married, she was already like 42 or something. Then she had a baby and had no complications in her pregnancy, which is like unheard of, but yeah. Yeah. They are an odd pairing. Okay, that took a little turn, but it's fine. We're back. Anyway, but in that data set, if you look at it, like there's one set of data, I can't remember, one set of data comes from, I think, one state, and the other set of data comes from a different state. And in one of them, the y-intercept is like -7. So that means if you never dated, your marriage is gonna last -7 years. So that one wouldn't make any sense at all. But in the other data set, the 0 dating actually had a y-intercept of like 5. Like you would make it 5 years if you never even dated. And the people that dated a long time obviously made it longer. It depends on the state again, but it was like 0.5, 0.6 on the 2 different states, something like that. Yeah. Okay, so we did step 1, which is find the slope. We did step 2 almost. We haven't actually finished step 2 yet. Why? Because we got distracted. Why haven't we finished it yet? Because you're slow. I don't know. Okay, so we have a slope, and now what do we have? A B, which is a what? It's not a B. What is it? It's a y-intercept. So now I can put those together, and I have y equals what? M x plus, oh, not plus, whoops, minus 19. What is that? That's everything, actually. This is your regression equation. Did you hear what Peyton said? He said that's the thing that you plug the stuff in, it gives you your answer. Yes. Plug 12 in that, you have your answer. Okay, try it. So y equals 3683.33 times 12 minus 19, 566.62. Say it again, 24,000. So interpret that answer really quick. Like in a sentence, tell me. So a woman in this data set, or a woman in this age in the US, who graduated high school and did not attend college is expected to make $24,633.34. How much, give or take? How far off is my guess? No. This is where step 3 comes in. Okay, pause, time out. Over here, I said, how much give or take? And the answer was $26,000, right? But this is just, if I'm just talking about this, if I'm just talking about the income, okay? So if a person walks up to me and says, how much money do you think I make? Someone in that data set, in that age range, right? How much money do you think I make? This is awkward, I don't know. I say, oh, well, how many years of education do you have? I'm not telling you. Okay, you defiant little. Great. What is my guess? If she gives me no information, my guess based on her attitude is that she doesn't have a freaking job. So $0, yes. Okay, if she gave me a little less attitude and just said, I actually can't give you that information right now, then I would just guess average, yeah? If I have no other information, that is my guess. If one of you walked up to me and said, what do you think my GPA is? if someone I didn't know walked up to me and said, what do you think my GPA is? I would just get, well, the high school average is 3.4, so 3.4? Just kidding. I don't really know what it is. But if I don't know, I would just have to guess average, right? There's really no other way, unless you can pick up a few clues. I mean, if he's got that real nerdy look about him, then I might go a little low up. If he's got that other look about him, then I'm like, yeah, okay. 2.6 tops. Just kidding. Okay, but either way, I am much better off if I am allowed to put some sort of give or take on my answer, right? But we talked about how ridiculous this data set is. My guess is $32,000, give or take 26,000. Okay, wow, good job. Okay, but that give or take, listen carefully because this is important. That give or take, this right here, is only the give or take if this was your guess. Okay? If you never, ever, ever went through this process and found this line and used this line to make your prediction, if all you did was just guess that, then this is how big your error is. Now, if instead I say, what's your education level? How many years of schooling do you have? If she's kind enough to respond, give me a number. Sure. Then, if she tells me that she has 12 years of education, do I know a little bit more about her? Is it likely that I could make a little bit of a better guess? Yeah. In fact, I mean, even not having the full equation of the line, I could go, okay, 12 is a little lower than that, so I think her salary is a little lower than that. Voila. Yeah? But if I take that 12 and I plug it in here and I get this prediction, then my error, my give or take on this error, my how far off am I, is that formula that's on your page. Yep. So the RMS error, if you use the line, is, notice, what was our error before? It was the SD of the Y's, right? That was our give or take. But this time, when I take the SD of Y and I multiply it by 1 minus R squared, you probably don't believe me right now, but that's actually going to multiply this by a number less than 1, and it's going to make it a little bit smaller. Does it make sense to you that with more information, my error is a little bit smaller? I can make a little bit better guess because Haley was willing to share that information with me. Yeah? Okay, so plug this in for me. So you go 26,000 times the square root of 1 minus 0.34 squared. Please make sure it actually looks like that in your calculator. Make sure the 1 minus 0.34 squared is all under the radical. Did you get 24,000? 451. How many cents? Okay. Now, you have to remember what the error was before. What was it? 26,000. So if we've reduced it to 24,000. So now I say to Haley, Haley, my guess is that you make about $24,000. Give or take 24. I guess, Haley, that you make somewhere between $0 and $48,000. You're welcome. Yeah? So why is that, give or take, why is that error so freaking big? 2 reasons. Because this SD is way huge, and this correlation is way low. There's not a whole lot we can do with that type of data. Yeah? You will see when the correlation is higher that there is a huge drop from SDY to this RMS error. Technically, though, just so you know, looking at your yellow and green packet, they're both called RMS error. This is the RMS error if that was your prediction. This is the RMS error if you use this to get your prediction. Yeah? So remember I told you I put the things on the formula page in order. So you do not ever jump to RMS error if you didn't do these top 3 or 2 really things. Does that make sense? Do not use that formula for RMS error unless you've already used the slope and the equation of the line. If it asks for RMS error, so go to yellow. Look at question. So question 7. So let me explain this data set a little bit. It's a little bit confusing for some people. This data set on commute time and well-being score. What is commute time? How long it takes you to get to work? Yeah? Technically, it's both ways, I think. How much time you spend in your car in order to get to work every day and home. Okay? And then your well-being score, some sort of magical combination of maybe your weight, maybe your eating habits, maybe your blood pressure. I don't know. I don't really know what it is. Okay? Basically, it's a measurement. It's a numerical number telling a numerical number. Yeah, definitely. It's a number telling you how healthy you are. So look at that data set. Notice the R value. What is it? Negative. Why? Why is there a negative correlation? As commute time goes up, what happens? Your health and happiness go down the toilet. Okay? Do any of you know anybody that has a really long commute? Some people make the most of it. They're all about their podcasts and their books on tape and their healthy snacks. Some people not so much. Yeah? Some people are fine. Some people, it just doesn't really work well. Okay. So anyway, in general, okay, the longer your commute, the lower your health index score. So the question on number 7 says, what would you predict as the well-being score of a randomly selected commuter? So somebody that was a part of this data collection process says, well, what do you think my well-being score is? Well, how long do you drive to work every day? I'm not telling you. And your answer is 70. Except they've got attitudes, so they might be a little pissed off, so they might have a lower score. You deserve a 2. Okay. So you would guess 70. And give or take on that guess. It's 5. Your RMS error. So question number 8 says, what would the RMS error be for your estimate in question number 7? Did you use the equation of the line in number 7? No. So your RMS error is strictly your SD. Yeah? It's going to ask you for RMS error again somewhere down the road. Yeah, that's where it does. The questions go in different order on the yellow and green packet, so don't be all 9. Gosh. Okay. Anyway, yes, so the RMS error on number 9 says, what would your error be if the prediction was made using the regression equation and knowing a person's commute time? Then your error would go down. You would plug it into this formula, and it would tell you how much, give or take, there is on that guess. Does that make sense? Okay. But you actually have done all the work beforehand. I'll show you. Yeah. So as you go through these, now look at green for a second, because people get mad at me with green because they think I was being deceitful. I wasn't meaning to be. So on the green worksheet, the first thing it asks you to do is make predictions based on an SAT score of 430, 510, and 700. How do you do that? And then get the regression equation and plug those numbers in. Yes, that's option number 1. But when Karanda was here, you learned another possible way. Yeah? Where I just look at this and I see, okay, 430 is one standard deviation below average. Can you see that if you look closely at it, now that I've told you? Okay, so if 430 is exactly one SD below average, don't stop before you write 2.5 on your paper, because if you write 2.5 on your paper, I'm going to cry. One SD below average on the X means R SD below average on Y. Remember on your SD line, it would be one SD is one SD. But we're now, when we're making predictions, we've got to be using the regression line, which is not that same slope. So if you're going down, like if you know that your X value, your 430, is exactly one SD below average, okay, then the Y value that goes with this, so the GPA that goes with this, is 1 times R times the SD of Y below the average of Y. You remember that kind of? Now, you do not have to do it that way, okay? But don't get all mad at me when you get to question number 7. Read question number 7 in the green packet. So, if you already did question 1, 2, and 3 using the regression equation, do you need to do number 7? No, you just need to write the equation on number 7. Or you could start with number 7 and then go back and do number 1, 2, and 3. Okay, the reason it goes in that order, and then look what it's going to do on number 11 and 12 and 13. Is this a big packet? Is this a lot to do? No, you're doing the same thing twice. Okay, if you did it this way on the front page, then you would now write the equation of the line and plug them in and do it that way and just make sure that they match up. If you decided to just go with the equation in the first place, then you've basically already done the second page when you're done with the first page. Does that make sense to everybody? That's why it's on there twice. It's not because I'm weird and I'm dumb and whatever other things you say about me behind my back or when I'm not here. Okay. So that's why it looks like that. And it's kind of like that on the yellow packet too. The questions just go in a slightly different order. I didn't want to give you 2 identical packets and have time to do one of them with you, and then all you have to do is like, because then you wouldn't learn anything. Promise. Okay? Any questions for me? You will not be able to answer question number 15 on either packet. We will do those after the break. But you can still turn them in. We'll just dig them back out. I'll grade them and put them on your grade. And then we'll do question number 15 after Thanksgiving. There is no other homework. There are no other assignments besides these. So getting caught up and doing these, if you get these done, turn them in, you have nothing else to do until after Thanksgiving. Do you understand? Okay. Yeah. Oh, okay. I'll let him know. Okay. He gets excited when he knows the answers before I teach him anything. It's fine. Okay, I forgot to... Oh, he had a question about it. Oh, I see. Okay, so let me take roll really quick because I forgot to do that. Okay, so as you're working on stuff, if you have questions, feel free to email me. Or you can come in before or after school. You can come in on the day you're not supposed to be here next week if you need help, whatever. Just let me know. I'm just saying if you need help, and if you just miss my face and all the laughter.